Assalamualaikum all. This is video about our group project for BMMP3584 Advanced Machining for 5-axis machining project. So our lecturer for this course are Technologist Dr. Sharul Azwan bin Sundi alias Swandi and Technologist Muhammad Shafiq bin Jumali. So before I going through about our presentation, let me introduce about my team members. My name is Fadli Arifin bin Muhammad Shabli, and next is Muhammad Akil Rafiq bin Azaman. Next, Lo Kazin, Nur Shazlina binti Romzi, and lastly Zuli Aida Syairah binti Zulkifli. So, CATIA software is versatile and used in various industries, including aerospace, construction, machinery, and electronics. So, the cutting tools and workpiece movement is controlled by numerical control programs by generate manually or using CAD/CAM software. So this project is aimed to create the fixture using CATIA V5 by utilizing its features to complex surface and irregularly shaped parts and demonstrating 5-axis machine process aspect. So our objective of this project is to design the fixture by using CATIA, to determine the process of machining involved in the production of fixture, to produce the product through 5-axis CNC milling machine. So next is about our organization chart. As you can see here, our leader is Akil Rafiq, and the assistant leader is Lo Kazin, Zuli Aida Syairah and Nur Shazlina as a designer, and lastly me as a programmer. So that's all from me. I will give to my next presenter, Akil Rafiq. Thank you.
Okay, for the next slide is project planning. Firstly, we identify and meet the stakeholder, and second, define scope. Third, set on objective. Fourth, determine the deliverable. Fifth, create the project schedule. And fifth, risk analysis. And lastly, set the progress report guideline. Okay, for the Gantt chart, as you can see here, we have two label, which is green label and yellow label. Green label is what we are planning to do, and for the yellow, what we actually do. And first, this is our planning to complete the project for the subject advanced machining. We start to choose the title of the product at week 3 until week 5, and we actually decide the title at week 5, and then we present our project report at week 10 until week 14, and we actually do is at week 14. Okay, next is 3D modeling. As we can see from the left side is top view of the fixture, and then left view, front view, back view, right view, and isometric view. The process planning of this project. First, we design the product, and then we scheduling and production control, and lastly, machine tools. Process planning is a crucial pre-manufacturing activity that outlines the sequence of the operation required for a product or assembly, particularly in a workshop producing unique or rare items.
Now I would like to present about the group task for our project. First process is design idea, which is done by Kirsty, Sadrina, and Julie. The process which is done by Fadli and Akil is entering sketch, part design workbench, and preparation to CAM. The process which is done by all of us for our group member is machining plan system, assembly machining workbench, and machining sheet. And the process which is done by Fadli and Akil is video simulation. And for the last one, which is report is done by all of us, of our group member. Next, I would like to present about the machining sheet for our machining process plan. The part name of our project is picture part. Number of our group is group 1. The machine used for our machining process is DMG Mori 5-axis milling machine. The material of our workpiece is aluminum. We have do 5 steps for our machining process, which is facing, roughing, profile contouring, multi-pocket frame contouring, and isoparametric metric. For facing, we have used face mill with diameter of 63 millimeter. For roughing, we use M mill with diameter of 16 millimeter. For profile contouring, we use M mill with diameter of 16 millimeter, 10 millimeter, and also 6 millimeter. For the multi-pocket frame contouring, we use M mill with diameter of 16 millimeter. And for the last one, isoparametric process, we use ball mill with 6 millimeter of the diameter. Next is the machining and simulation for our process. The first process is facing process. The second process is roughing process. And the third process is profile contouring. And now is the multi-pocket frame contouring. Now is profile contouring. Next simulation process is isoparametric machining. For the last process is also profile contouring, but we use 5-axis to turn the tools. Next, I would like to present to next presenter.
Next, I will explain about discussion part. This is the isometric view of our product. The first one is side view, second is front view, and the third one is top view. This is a detail of measuring for our product. From this isometric view, we can see the measurement for right view, front view, left view, and also top view. This is more important to make sure the measurement is fulfill the requirement of assignment task or not. In addition, producing product by using 5-axis CNC machine involve challenge, including rectification of error, corrections of tool diameter and stock size for ensuring no error occur during processing. Next, when the selection of the process to be used are complete, the code for the production process has been generated. At first, the process went as planned. However, when entering the isoparametric process, the tool point has broken twice. There can be several reasons why a tool can break while machining on a 5-axis CNC machine. Here are some possible causes for the next slide. Here are some possible causes. First, incorrect tool selection. Selecting the wrong tool for a specific machining operation can cause breakage. We need to consider factors like material, cutting speed, feed rate, and chip evacuation. Second, excessive cutting force. 5-axis machining involves complex cutting paths, varying condition, and excessive cutting force. Third, improper tool setup. Incorrect tool installation, setup, and alignment can cause poor performance. Fourth is insufficient tool rigidity. Rigidity is crucial for tool stability during machining, preventing excessive deflection and breaking. Fifth is material-related issues. Hard materials stress cutting tool, such as improper selection, coating, and strategies increase tool breakage risk. The last one is programming error. CNC program mistake cause tool breakage due to collision, incorrect paths, and programming error.
As we can conclude in our project is advanced machining technologies revolutionize the manufacturing industry, improving precisions, enhance efficiency and also productivity. These technologies reduce production time, improve product quality and enhance design flexibility. Next, advanced machining impacts industries like aerospace, automotive, medical, and consumer goods by producing complex components, improve performance, and integrating with data analytics for increased productivity and cost saving. Third, advanced machining fosters innovations, drive new materials and designs, and allows manufacturers to push boundaries. However, skilled professionals are needed for effective implementation and also maintenance, making continuous training and upskilling crucial for fully harnessing the potential of these technologies. In this project, we encounter machining issues, including two tool breaks during isoparametric processes. The first break occurred due to the wrong isoparametric process location, causing the cutting tool to hit the workpiece surface. The second break was caused by incorrect cutting tool diameter, as the workpiece surface radius was not considered before determining the tool diameter. Last but not least, this project emphasizes considering potential situation before starting a program to prevent tool breaks and delays. That's all from our group. Thank you.
That's all for our group presentation. Thank you.